And this section is about exploratory data analysis, which is when you've got some data, some scores or measurements or numbers, and you want to explore what's going on with your data and how it's distributed. And the main thing we're going to talk about in this section is taking those quartiles that we were talking about in the last section and displaying them, using them to show what's going on using what's called a box plot. So a box plot is something that looks sort of like this. This is an example of a box plot. It's sometimes called a box and whisker plot because it looks like a box or a rectangle with whiskers growing off the sides. So it's made up of a box, a rectangular box, with a line somewhere in the middle, and then these horizontal lines coming off the sides of the box, stretching out to the left and to the right. Or a box plot could also be drawn vertically like this instead of horizontally like this. I've seen them both ways. Our book does them horizontally, so that's the way I'm going to teach you. But if you go looking at box plots that other people have made, you might see some of them that are arranged vertically. But these box plots are based on what's called the 5-number summary of a list of data values. And the 5 numbers that make up that 5-number summary are the minimum or lowest value of all the numbers, and then the 3 quartile numbers, Q1, Q2, and Q3, which we talked about in the last section, and then the maximum or the highest value in your list of numbers. So that tells you where these parts of the box plot go relative to one another. So you have the minimum value, and then the box part goes from Q1 all the way across to Q3 with a line somewhere in between showing where Q2 is, and then the other whisker comes out to wherever the maximum is. So to actually draw a box plot, and you can draw one by hand, or you can get like a calculator or a computer to draw one for you. And at the end here, at the end of this video, if there's time, or if in a separate video, I will show you how that works if you wanted to try doing it that way. But for now, we'll just talk about if you're just drawing it yourself on paper, how you would draw a box plot for a set of numbers. So first you find the 5-number summary. You find Q1 and Q2 and Q3, like we talked about doing in the last section. And also, you need to know what the minimum and the maximum values are. So those 5 numbers make up the 5-number summary. Draw a scale for the data on the horizontal axis. So if you're doing this on graph paper, make sure you use a consistent scale where 1 square on the graph paper represents an increase of 1 or 2 or 5 or whatever's convenient, but make sure it's consistent. So there should be the same amount of space on your graph paper between 10 and 20 as there is between 20 and 30, and between 30 and 40, and so on. And you have to make sure there's room to show the whole range from the lowest to the highest of your set of data values. Then draw a box that stretches from where Q1 is to where Q3 is. Draw a vertical line through the box at the median, which is Q2, and then plot points at the minimum and maximum values and draw horizontal lines connecting those points to the box. So let's work through an example. And before we do that, I'll just mention there is a variation on a box plot that you will sometimes see. I won't ask you to do this, so this isn't something that you officially have to know about as part of this course, but you might see these if you go looking at box plots that have been published in various places. A variation on the basic box plot that we've talked about here is what's called a modified box plot, and that's where the whiskers, instead of extending out to the highest and lowest of all the values, they extend only to the highest and lowest values that are not outliers, that are not within 1.5 times the interquartile range of the box. And then if you do have outliers, those would be shown separately as individual dots or circles or stars or something like that. So let's work through an example where we draw a box plot for this list of data. And if this looks familiar, we use this in an example from section 3.1. These were the salaries in thousands of dollars of the employees at one of the companies we were talking about. So somebody was making $14,000, somebody was making $22,000, and so on. But we're going to take this list of numbers and draw a box plot for the data. And so the first thing we have to do is find the 5-number summary. So we need to say what the lowest number is, what the highest number is, and what those 3 quartile numbers are. So to do that, first we will arrange the data in order. So here they are arranged from lowest to highest. And then we'll start by finding the median. That's going to be Q2. When we have an odd number of data values like this, the median would be the one right in the middle. So here that would be the 28. So that is the median, which means that is Q2. Now to find Q1, look at the values that are below the median. And I'll just mention that there are different ways of figuring the quartiles. Some software packages or some statisticians use one method, some use another method. For example, some people would include this median when they are looking at the bottom half of the data to find the Q1. Some people will not. I will not. I will just look at the ones that are below that median. That's the way our book does it. That's the way a TI graphing calculator will do it. So that's the way we're going to do it for this class. But if you go looking at how other people do it, you might see that different people do it different ways. So now, looking at the numbers that are below the median, that would be these 4 numbers here. To find the median of those, it would be halfway between the 2 middle values, the 14 and the 18, which would be 16. So that's our Q1. And then for Q3, take the numbers that are above the median, that would be these 4, and find the median of those. So halfway between the 33 and the 65, and if you're not sure what is halfway between 33 and 65, remember you can sort of average them together. You can add those 2 numbers together and divide by 2. So 33 plus 65 would add up to 98, and then 98 divided by 2 would be 49. So Q3 is 49. That's the median of the part of the data that are above the overall median. And then the lowest number of them all, the minimum, is the 12. And the highest number of them all, the maximum, is the 100. So those 5 numbers, 12, 16, 28, 49, and 100, make up the 5-number summary that our box plot is going to be based on. So now, let me start by drawing the box. I've gone ahead and labeled this axis. I need to have room to show numbers at least from 12 up to 100. So I've gone ahead and used the squares on the graph paper. I've gone up by 5s, but I've only labeled the 10. So here's 10, 15, 20, 25, 30, and so on. So the box part of the box plot is going to run from Q1, which is 16, to Q3, which is 49. So there's that. Here's 15, so a little bit past that would be 16. And then a little bit before 50 would be 49. So the box runs from 16 over to 49. And then inside the box, I draw a line, a vertical line, showing where Q2 is. that would be at 28. So a little bit to the left of 30 at 28, there's my line for Q2. So the box shows where Q1 and Q2 and Q3 are. And now my minimum is at 12, so that would be right about here. And my maximum is at 100, that's way up here. So I draw the whiskers, the lines, from the edges of the box down to the minimum and up to the maximum. So there is my box and whisker plot. Now, what does that tell us? What are we looking for if we look at a box and whisker plot like that? Well, for one thing, relating to when we were talking about in the last section about outliers and the interquartile range, I said that the interquartile range is Q3 minus Q1. So that would be how wide the box is. It's how far it is from Q1 over to Q3 or vice versa. If we take something that's 1.5 times as long as that and go out past the right edge of the box or past the left edge of the box, anything beyond that would count as an outlier. So here the 100 is out past 49 plus 49.5, which means it would count as an outlier. The other thing to notice about this is that it's not symmetrical. The two halves are not the same size. The left half of the box is smaller than the right half, or in other words, the line in the middle is not exactly in the middle, it's further to the left than it is to the right. So this part of the box is smaller than this part, and then this whisker is a lot smaller than this whisker. So it's like the right half of our data set are a lot more spread out than the left half. There's a lot more space between Q2 and Q3 than there is between Q2 and Q1. And there's a lot more space between the maximum and Q3 than there is between the minimum and Q1. So we would say that this set of data is positively skewed or skewed to the right, because the box plot is a lot more stretched out on the right side than it is to the left side. So at the end of section 3.1, I talked about what it meant for a set of data to be positively skewed or negatively skewed. And so you can see that by looking at the box plot. This is positively skewed. So looking at a box plot, you should be able to tell, is it positively skewed, that is skewed to the right, or negatively skewed, or neither one of those. So let's try some examples. This is a modified box plot. It's got the outliers shown separately, but looking at this, would you say it's skewed to the right or to the left or neither one of those? I'd say it's skewed left, that is negatively skewed. The left whisker is longer than the right whisker. The left half of the box is longer than the right half. Even without these outliers, this is skewed to the left or negatively skewed. What about this one? Okay, this one would be positively skewed or skewed to the right. And what about this one? Well, this one looks pretty symmetrical. Looks like the two sides of the box are both about the same size and the two whiskers are about the same length as each other. So this looks pretty symmetrical, not skewed either way. Okay, so that's mostly all I wanted to say in this section 3.4, but I will come back and in a separate video show you how you can do box plots and the 5-number summary on a graphing calculator or a computer.